Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we're going to still talk about factoring because there's so much to say about factoring. I love factoring. It's one of my favorite things to work on in math as a whole. Right after ratios, I love middle school ratios. I think they're so real life and so phenomenal, but different topic, different day. Today, we're going to factor out the greatest common factor first, and then we're going to focus on factoring the rest of the problem, just like we did in the past video. Okay, so we're going to get right to it. And one thing that I want you to notice is every single one of these 6 problems that we're going to do in this video has something that's in common between every single term, okay? So my A term, my B term, and my C term, there's always something that's the same, right? And regardless of what it is, I know that I can basically divide each of my terms by that same commonality, right? So for example, in this particular piece, I can see that all of my coefficients and my constant, they're all even numbers, right? If they're all even numbers, what's going to happen is we can divide each of those numbers by 2 at the very least. Well, in this case, at the very most, because 2 is only divisible by 2 and 1, right? So what I'm going to do is when I factor that GCF out, what I'm going to do is I'm going to actually put that number in front of my parentheses. And whatever's going to be left in the parentheses is going to be what's happening after I divide each term by 2. So for example, in my head, what I'm going to do is this divide by 2, divide by 2, divide by 2 business. This is something that doesn't usually get shown, even when people say, or, you need to show your work, even when teachers are like, you need to show your work for this, blah, blah, blah. Like they get cranky. I mean, I've been there, so I know exactly what they're talking about, right? This is something that doesn't really get shown very often. So we're doing 2 divided by 2 in your head. That's going to be 1. So we'll be left with x squared. 8 divided by 2 is 4. So I'm going to have 4x. And then 42 divided by 2 is negative 21. From this step, after we've pulled that GCF out, now we can go ahead and factor like we normally do based on what we did in the previous videos, right? So in here, actually in the first video of my factoring playlist set. So in here, I'm still going to keep this 2 because if I want the same exact expression, I need to keep everything that I've pulled out outside of the parentheses so that when I distribute it back, it's going to give me that same expression at the very top, right? So then in here, we know that x squared is going to be x times x. And then 21 is going to be 7 times 3. So if I do 7 minus 3, I get positive 4. So this will be a positive 7, negative 3. Again, if you want to pause the video, I strongly urge pausing the video, attempting the next problem on your own, seeing what you can do, what you can factor out as a GCF. And even as I go through the problem, continue to pause it, rewind, come back. I know I talk a little bit quickly, maybe put me in slow-mo if you need to. That should help, okay? And if not, we've got 6 problems that we're doing together, so ta-da. Okay, so in this particular problem, what's happening is that I don't have a coefficient here, right? But what I do notice is that I have an x, an x, and an x in each of my terms. Now, what's interesting is my x to the third has 3 x's, right? It's kind of like saying x times x, right? This is saying like I have 4 times x, whoops. And this is saying I have negative 60 times x. Notice how each of them have this, have an x that's in common between all of them. So what I'm going to do is I'm actually going to pull that x out, and that's going to be kind of like in place of my 2 in the first problem. So then I'm going to go ahead and divide each of these terms by x. What's really nice about writing the terms out like this is you can see very clearly what is left over and what you can go ahead and put into your parentheses. So x to the third divided by x is going to be x squared plus x, 4x, right? Because that's what's left over, and then minus 60. Again, I can absolutely go ahead and factor this out. So I'm going to do one parenthesis, another parenthesis. Here's x. X still stays, right? X squared is going to be x times x. And then negative 60 is going to be, I know I have 1 times 60, and I'm not going to focus on the negative so much. I'm going to kind of use those in my head, but at least label all of my factors for 60 first, right? So I'm going to have 1 times 60, 2 times 30, 4 times 15, 5 times 12, 6 times 10. I think that's it. Yeah, that's it. Those are the only whole numbers. And again, we're focusing on just whole numbers in this particular chapter, in this particular set of problems, because that's just what we're focusing on. Ta-da! So I know that if I need for them to add up to +4, I know I'm always going to kind of start at the bottom, work my way up. I also know that 10 minus 6 is 4. So I'm going to have a +10 and a -6. Again, you can absolutely go ahead and check the work if you need to. Some teachers might actually require it, some might not, who knows? But that's kind of where we're at. That's the answer. And then you get to move on. So this problem is a completely different problem altogether. Not all of my terms have an X, and I don't have like a number that's higher than 1 as a coefficient for my X squared, right? But what I do have is this negative number in front of it. So this piece right here, I want to get rid of that. I don't like when when my X squared is negative for a lot of reasons. It's just more challenging to factor it that way. So what I am going to do is I'm going to remove this -1, and I'm going to divide each of these by -1. Okay. So when I divide by a -1, all I do is change the symbol, right? Change the negative to a positive, the positive to a negative. So then I'm going to have x squared plus x minus 12. And then again, I can factor this out. Whoops. But I still need to keep that -1 in front of my parentheses. So again, x squared is going to be x times x. 12, the factors of 12 are going to be 12 times 1, 2 times 6, 3 times 4. And again, I'm going to start from the bottom and work my way up. Actually, 4 minus 3 is 1, which is exactly what I need in this number here. So I'm going to do +4 minus 3. Now, one thing that I do want to say before we move on to the next problem, I know I make things look a lot easier than they really are. I do a lot of math every day. So, and I've been doing a lot of math for a long time. So when you're at this point, it does look easy. It does feel a lot easier, right? The more practice you get with factoring, the better you're going to become at factoring. So I would recommend attempting additional problems on your own time, maybe using a program that gives you an answer key, or just searching up factoring like worksheet with a PDF and answer key, kind of like using that in your code words when you search. Okay. So this problem, very similar to the previous problem where we have a negative, right? So we know we're going to absolutely pull this negative out because we can't have negative x squared. It's just not helpful for us. But then I also have a 5 here, so we got to make sure that everything else is also divisible by 5, so we can pull that 5 out as my GCF. And it turns out that 5 goes into 5, right? And then also 5 goes into 60. So my GCF is -5, and I'm going to really go ahead, I'm going to really go ahead and divide each of these terms by -5. So in here, they'll cancel. I'll just be left with x squared. In here, because I'm taking a positive and dividing by a negative, it's going to be -x, right? And in here, again, because I'm taking a positive and dividing by a negative, it's going to be -12. Now, again, here, they're both negative, so that's why this is positive, and that's our goal. We can absolutely factor this again. So we're going to bring down this -5. and go ahead and open up two sets of parentheses, factor x squared. So x squared is x times x. And then let's go ahead and let's take a look. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. But this time I'm looking for a negative 1x, right? Like that's the goal. So I know that I'm going to always start at the bottom and work my way up. 3 times 4 is 12. 3 minus 4 is actually negative 1. So in the previous problem, we did 4 minus 3. But in this problem, we're going to do 3 minus 4. Because we're looking for a different number here, right? Here we're looking for a negative 1. And here we were looking for this positive 1, right? And with this positive 1 that we're looking for, this is the only thing that made sense. And then, ta-da, final answer. Okay, again, please try these problems on your own. See what you can do on your own before you go ahead and just watch the video and see the final answer. It should be helpful. Okay, let's take a look at this, right? So in here, I've got my A is larger than 1, so we've got 3. We've got 36, and then we've got 96. So 3 should be able to go into each of these numbers because 3 goes into 3 and 6 and 9. So I'm going to pull a 3 out of every single term. So again, I'm going to do this math in my head where I'm going to divide by 3 every single time. So 3 divided by 3 is x squared. Negative 36 divided by 3 is negative 12. And 96 divided by 3 is going to be 32. So let's take a look. We can absolutely factor this again. And let's take a look at my factors of 32. So 1 times 32, 2 times 16, 3 doesn't go in, 4 times 8, 5, 6, 7 don't go in either. So let's see if I can start from the bottom and work my way up. I'm looking for a positive 32. That must mean that these are either both positive or all negative. Because I'm looking for a negative 12 for my factors to add up to, because it's supposed to be negative, they're all going to be negative, right? So if I add negative 4 and negative 8, I'm going to end up with negative 12. Again, x squared is x times x, negative 4, negative 8, final solution. And if you do want to distribute fully to get back to the original problem, totally doable, okay? All right, last problem. If you haven't paused the video yet, definitely pause it, try this one on your own, and then come back to me. Okay, so I see a 4, 36, and 72. I don't see any x's, but what I am going to do is I'm going to just change this up a little bit. I'm going to share with you what's going to happen when this is to the third, when this is to the second, and this is just plain old x. Just because I want you to be able to see a number and a variable, not just a variable, not just a number on its own, because sometimes it's possible that that'll work out. So I know that each of these is divisible by 2. Like if I take 4 and divide it by 2, I'll get 2. 36 divided by 2, I'll get 18. And 72 divided by 2, I'm going to get 36. But I also know that each of them is also divisible by 4 because the numbers that I got afterwards happen to all be even again, right? So I'm going to divide each of these by 4. And I'm going to divide each of them by an x, because in each of my terms, I have an x available to me. So I'm going to pull 4x before my parentheses, and then I'm going to go ahead and divide. So taking a look, this is like saying I have 3 x's, right? So I have x times x times x, and I'm dividing by one of the x's, right? So one of them is going to kind of go away, and I'm going to be left with x squared. This is kind of like the goal, right? We want our first term to be x squared and nothing else before we go ahead and open up two sets of parentheses and factor things out. So in this case, I have x squared, so that's like two x's that I'm dividing by one of the x. These guys will like cancel out. I'll be left with one of the x's. And then 36 divided by 4 is going to be 9. So I'm going to do plus 9x. And then in here, I'm going to do x divided by x. So these guys will cancel. 4 goes into 72. I'm going to do this math right quick here because I want to make sure I give you the right answers, not the wrong answers, because that would be so sad. Okay, and then I have 18 here. Now let's take a look at my factors of 18. My factors of 18 are 1 and 18, 2 and 9, 3 and 6, and 4 and 5 doesn't work. So when I open up my two sets of parentheses to fully factor this problem, I'm still going to keep that 4x in front of the parentheses. So it doesn't quite matter what you're factoring out. Whatever it is, you're just going to have to keep it in the front, whether it's a number, whether it's a positive or a negative number, or whether it's just a variable or a variable and a number. Whatever it is, you're keeping it out, you're keeping it together. X squared, my goal. I'm going to have x and x, right? X times x is x squared. And then again, I'm going to start from the bottom and work my way up. I know that 3 times 6 is 18, but I also know that 3 plus 6 is 9. So I'm just going to go ahead and do plus 3 plus 6, final answer. All right, join me in my next video where we're going to talk about these special particular factoring problems. Bye.